This is part 2 of section 4.3. We're solving word problems using two variables. Let's work a distance problem. With distance problems, pictures often help. We're going to use the formula D equals RT, which is distance equals rate times time. Okay. A train travels 150 kilometers in the same time that a plane covers 400 kilometers. If the speed of the plane is 20 kilometers per hour less than 3 times the speed of the train, find both speeds. There's a lot going on in here. Okay, so what I'm going to do is I'm going to make a chart, seeing if I can organize some information. So if I have a train, and then I have the plane. Okay, we're given distance for both of them. The train goes 150 kilometers in the same time that a plane covers 400. Okay. We're looking for the rates, so I'm going to say X and Y. And then we're told that the times are the same, right? In the same time. Okay. So one of my equations is going to be, if I can find a way of talking about how long the train went in terms of these, and then how long the plane went in terms of these, then I can set the two times equal to each other. Let's come up to this formula. If I want time, I can divide both sides by R, so that I get time is equal to the distance over the rate. So right here, I can do distance over rate, which would be 150 over X, and this will be 400 over Y. So my first equation can be 150 over, not 150 over X, 150 over X is equal to 400 over Y. And that's not really in a good form for us to use. So let's cross multiply. To get 150Y is equal to 400X. Okay, let's look at the other equation. I might want to simplify that a little bit more, but let's look at the rest of this. We've used this, we've used this, we've used it at the same time. The next part, if the speed of the plane is, well, what is the speed of the plane? That's Y. So Y is 200 per hour less than, so this is going to be a subtraction that makes it tricky, 3 times the speed of the train. Well, 3 times the speed of the train would be 3 times X. The speed of the plane is, so that's Y is 20 less than 3X. So 3X minus 20. So the system I need to solve is Y equals 3X minus 20, and 150Y is equal to 400X. That's the system we need. Okay, this is set up for substitution, so I'm going to take all of this and plug it in right there. So I get 150 times Y, where Y is 3X minus 20, is equal to 400X. All right, let's distribute. 150 times 3 is 450, minus 150 times 20 is 3,000, is equal to 400X. Let's subtract 450 from both sides to get negative 3,000 is equal to negative 50X. Divide both sides by negative 50, and we get 60. So I found my X value. I'm asked to find both, so I'm going to take this and plug it in right here to find my Y. Y equals 3 times 60 minus 20. Y is equal to 180 minus 20, which is 160. So I found X, which is my train. The train is going 60, what are my units? kilometers per hour, and the plane is going 160 kilometers per hour, and that would be my answer. Okay, so let's look at an investment problem. We always use the formula I equals PRT. The interest is the principal times the rate times the time. If the time is not given, we use 1. Okay. An investor must invest a total of $15,000 in 2 accounts. One pays 4% annual simple interest. That annual tells me that my time equals 1. And the other 3%. If he wants to earn $550 annual interest, how much should he invest at each rate? Okay, so I need to assign some variables. I know I have 2 investments. So let's say I have X dollars invested at 4%, and I have Y dollars invested at 3%. Okay, let's look for some bits of information we could use to get our equations. The total of these 2 investments must be $15,000. So that means X plus Y, if I'm adding the amount invested at each rate, that has to equal 15,000. So that's my first equation. Okay. Now what we know is if I can find the investment made on this, the amount of interest we make on this investment, and then add to it the amount of interest we make on this investment, it should equal 550. The interest is the principal, which is X and then Y, times the rate, which is 4% and then 3%, times time, but time is 1. So for this investment, the amount of interest I get on that first one will be 0.04x. The amount of interest I make on the second one will be 0.03y. And then if I add those together, I get 550. So my second equation is 0.04x plus 0.03y is equal to 550. Okay, this is set up probably for easiest to get rid, use elimination. And let's just say I'm going to get rid of y. I didn't leave myself a lot of space on the left, so I'm going to write it this way. I'm going to multiply everything by a negative 0.03. That will give me what I need to get rid of y here. So when I multiply by that, I get negative 0.03x minus 0.03y is equal to 15,000 times negative 0.003, which will give me a negative 450. And then the second one, I recopy. Add these together, you get 0.01x is equal to 100. Divide both sides by 0.01. And we find that x must equal 10,000. So now we need to find how much was we need to find y. I'm going to take this and I'm plugging it into the first one. 10,000 plus y is equal to 15,000. So y must equal to, subtract 10,000 from both sides, 5,000. So this person invested $10,000 at 4% and $5,000 at 3%. Okay, again, this could have been done with one variable. The way we would have done it before with one variable is I would have said, okay, we have X dollars invested at 4%, and then we had $5,000 to split up. If I used X, then I'd get Y. So I would do, instead of writing a Y here, I would have written $15,000 minus X. If you look at this first equation, if you subtract X from both sides, you would have had $15,000 minus X. Again, When you set it up with one variable, you're actually doing the substitution method without writing anything down. That's why it ends up more difficult. I do not care whether you work these with one variable or two, just whatever way you see it first, get it done.